Hello, good evening everyone. My name is Radha Krishna. I'm a faculty at IIT Madras in the Department of Electrical Engineering. I work in wireless communication and cellular systems. I have been here at IIT Madras for the last 8 years. So today I will share some of my views on 5G technology and the Indian 5G testbed in this talk. So let me just give you a brief overview of the talk before we start. So the talk is divided in two parts. The first part is about the core 5G technology. What does 5G mean and how is it better than 4G? What are its defining features? This is what we are going to discuss in the first part. In the second part, which is a shorter part, I will briefly go through the Indian 5G testbed and tell you what exactly is happening in the 5G testbed. Okay. So in the first part, I'm going to cover what exactly is 5G, how is it going to impact us, how are we going to get ready for the 5G. Okay. So like everything, before we start, a little bit of history on what these different generations are is going to help us to put everything in perspective. Okay. So I'm going to start with 1G, 2G up to 5G and explain you who defines this 5G, and then from there we look into the 5G technology as such. Okay. So we start at the very beginning, the first generation cellular technology. So this was invented at 1980. So this was got deployed around in 1980. It's primarily an analog system that almost uses FM. Okay, it's a frequency division multiple access system. So it's very similar to FM that we have right now. It's mainly a voice-based system, and there were three contending technologies for this: the AMP system, the NMT system, and the TAC system. The TAC was from the UK. Finally, the NMT and the TAC system got overwhelmed by AMPS, and AMPS was the ruling 1G cellular system. If you look at its key characteristic, it's an analog system, and it operated multiple users using FDMA technology. So essentially, users were divided in frequency, and they were able to access the network using different frequencies. Okay. So if you look at the effective speed, I mean, for analog systems, defining the speed is difficult, but if you look at the effective speed, you're talking about a few kilobits per second. Okay, that's what was 1G giving us. So just move ahead by a decade. In 1990, we have the 2G cellular system. So this is the first time a digital communication system was used in a cellular system. Okay, the underlying technology is called GSM, and the technology is called GMSK. And if you look at it, voice is still predominantly the main application for this 2G cellular system. However, data there was an option to send data on this network. Okay, and you are talking about speeds of up to 64 kbps. See, second generation cellular systems and GSM are still prevalent today. Actually, in India, a lot of coverage is through GSM. I mean, this is true for a lot of developing countries also. And after 2G, you have a little bit of improvements on 2G called the 2.5G. I mean, that's not a technical thing, but I just mentioned as 2.5G. We had GPRS, Edge, which provide a little more higher data rates. And at that time, email and web browsing just started on the cell phones. Okay, they did not start on the cell phones. The cell phones were used as modems to other computing devices to do the web browsing and email. Okay, but still, 2G system was still a voice. I mean, it's mainly meant for voice. Okay. Then, after a decade later, in around 2000 was the introduction of the 3G cellular system. Okay. The 3G cellular system, there were two main technologies. One is the WCDMA and the other is the HSPA. If you look at this, one of the main goals of 3G cellular infrastructure was high-speed data. Okay, so at that time, high speed was 2 megabits per second. Okay, that's a huge improvement over the 2G systems. And of course, another important thing that happened in the 3G was enablement of global roaming. So essentially, a phone in India can be used anywhere abroad, and similarly, phones outside can also be used in India and everywhere else. Okay. So essentially, this is a time where they use 2 Mbps to do video streaming, simple video streaming, and look at mobile-based television television broadcasting. So it's just the precursor to the smartphone era. Okay, So this is a time at which even actually China also did something interesting. China introduced TDS CDMA, time division synchronous code division multiple access. It's the first TD system that has been introduced in the cellular infrastructure. Okay, this is a very big landmark. Okay, so around this time when 3G was popular and 3G was being used, iPhone got introduced in 2007. Okay, and the first iPhone was actually on GSM technology, and GSM, and then of course on this 3G cellular. And once the iPhone got introduced, people started consuming data in a large, huge manner actually. And around the same time also YouTube also got introduced, so people started watching videos on trying to watch, at least try to watch videos using mobile phones and other things. Okay, this is also the time of Facebook, by the way. I mean, this was the 2000 to 2010 was a time where a lot of data hungry applications started coming into picture. Okay, so once these applications started coming into picture, the amount of data that has to be served by the network increased dramatically. Okay, so the 3G system was not able to handle that kind of a data load. That is when engineers started thinking, okay, we require a complete redesign of this network. We have to look at this in a completely different way, and that was the starting point of the 4G systems. Okay, so 4G systems came around 2010. So you can see every 10 years there's a new generation, and 4G was deployed about 2010. 2010 was a deployment, so it has been designed a little bit earlier. In 4G cellular systems, there were two key technologies: LTE, which all of us know right now, and WiMAX. WiMAX was a competing technology to LTE. So WiMAX was introduced by Intel, and LTE was introduced by other companies, including Qualcomm. And there was global competition on these both technologies, and finally LTE won, and LTE is now the de facto 4G cellular standard. When we call 4G, it's almost synonymous with LTE network. Okay. If you look at the data rates that this 4G was offering, you can realistically get about 10 to 20 Mbps of data rate on 4G cellular, and this is truly a data standard. Okay, so there was no mention of voice anywhere in this standard. So voice was also packetized as an IP packet and then transmitted over the network. Okay, so this is a truly data system, and its main goal was to increase the data rates and the experience of all the users. Okay, a lot of streaming videos were happening at this time of 4G cellular systems, and this is where Netflix entered into picture. Netflix and people want to watch 4K videos, look at holograms, play online games, and people actually want to now use the cellular infrastructure on 4G to do industrial control. They want to sit down at one place and control a robot in a different place. Okay, and now we are in this era of Internet of Things, where you want everything and anything to be connected to the internet network to become smart. Okay, so while 4G cellular systems were very good at providing good data rate, they were not designed for extremely large data rates, low delays which are required for online games or control applications, or they were not designed for large number of IoT devices. Okay, so from almost the last decade was the decade of 4G. Now if you now it looks like these 4G networks are getting congested, and they are not able to cope up with the existing demand for data and the QoS requirements of data. Okay, so this is the motivation for going to 5G. So what does 5G give you? 5G gives you all that is given by 4G, and in addition it gives you something much more. Okay, so that is what we are going to look at in this particular talk. Okay, so we have been talking about 1G, 2G, 3G, 4G and 5G, but who actually defines all these generations? What body defines these generations? Okay, so I'll just go into that for a few slides, because that's important to understand who sets these requirements and who makes these standards. Okay, this is part of the whole cellular saga. Okay, so just summarizing, this is a slide which summarizes what are the technologies and how much are the speeds and what are the main constituent underlying technologies. So if you look at 2G, it's a GSM, 3G CDMA, 4G OFDM MIMO, 5G is also OFDM MIMO. I'll tell you the differences. And you see that the speeds have been increasing every generation by almost tenfold. Okay. On the fourth, I actually put down the countries which were responsible for the development of these technologies. If you look at 2G was mainly a European standard. 3G was CDMA, which is mainly dominated by American company Qualcomm. 4G is one of the true global standards. There has been contributions from across the world, including US, Europe, South Korea, and China. 5G also the same people contributed, but India has also some small contributions in this whole 5G ecosystem. Okay, the next column is the deployment of these technologies in the global in all the countries, in all the other countries other than India. So 91 2G got deployed, around 2000 3G, 2010 was 4G, and 2020 was 5G. 5G deployments are already started in a lot of countries. Okay, if you look at India, 2G we had 2G in 95, approximately around 95. 3G was delayed because of reasons all of you know. It got delayed to 2010, and because of that 4G got delayed to 2015. So 4G came to India about only 5 years back, whereas in other parts of the world it has almost been a decade since 4G came. Okay, so they are moving, all of them are moving to 5G, and we have to understand when we can move and when India can move to 5G. I'm hoping that it will be in 2020 or 2022. So what is the body that defines this multiple generations? This is called ITU, International Telecom Union. Okay, so it's a UN agency. Since it's a UN agency, the members of this body are the countries. So India is a member of ITU. Similarly, US is a member of ITU. So all the countries are members of ITU. Okay, so any agreement that is made in ITU is legally binding to a country. So what ITU does is, ITU defines what a particular generation of the wireless standard is. Okay, so I'll describe this in a minute. So other thing that it does, very important thing that it does, is spectrum harmonization. Essentially, ITU looks at making sure that the spectrum is allocated for the required IMT technologies. Okay, so if you look at 3G, the code name 3G is a very colloquial name. The actual technical name for 3G is called IMT 2000. And 4G is IMT Advanced, 5G is called IMT 2020. As you rightly guess, they are separated apart by about 10 years each. Okay, so what do you mean by ITU defining XG? Does it make the technology? What does it define? Okay, so what does it define? So what it defines is, it defines the requirements of that particular generation. Okay, so here I just showed you an example of 3 different requirements, what are called as KPI, key performance indicators. Okay, so peak spectral efficiency, user experience data rate, average spectral efficiency. So for 4G, which is IMT Advanced, ITU defined these values as 15 bits per second per hertz, user experience data rate as 0.1, average spectral efficiency as 3 bits per second. For 5G, it increased all these values to some other numbers. For example, user experience data rate is increased by 3 times, average spectral efficiency is increased by 3 times. So what ITU does is, ITU has a list of metrics. For 5G, there are 14 such metrics. For each such metric, it defines certain values. Okay, and any technology that meets these values is called ratified as 5G. Okay, so what ITU does is, ITU defines the values, the key performance values, as well as the environments in which these values have to be met. Okay, so summarizing, essentially it sets the targets for each generation. Okay, so ITU sets the targets. Then who makes this technology for us? Okay, so one of the main body that makes these cellular standards is called the 3GPP. Third generation partnership. It's 3GPP means third generation partnership project. Actually, it was established in 1998. It was established for making 3G standard. Okay, from then the name stuck as 3GPP, even though we moved to 4G and 5G. So ITU sets the requirements. 3GPP makes the technology. 3GPP is one body which makes technology. For example, 4G, there was another body called WiMAX forum which made the technology WiMAX. Okay, But now predominantly 3GPP is the main dominant player in making cellular standards, and it's good to know something about 3GPP. Okay, so it is started for the, as I told you before, it is started for the development of 3G, and it's very instrumental in making 3G, 4G, and 5G standard. So all the phones that we are using now and all the base stations that are there across the world are compliant to the standard that 3GPP makes. Okay, so who are there in 3GPP? 3GPP is made up of companies. Technology companies make up 3GPP. Technology companies and research labs make up 3GPP. Okay, so they look at the latest and the greatest technologies in that decade, and they standardize the technology. So what I mean by standardization, essentially it means that they make sure that there are a predefined set of rules so that different devices can interoperate with each other. Okay, that is what is called standardization. Okay, so what does 3GPP do? 3GPP gets together all these technologies, make sure they are working well, and then they send it to ITU for ratification. Remember, ITU is the one which makes the requirements. So this is a technology which is the answer to that requirement. So once 3GPP makes this technology, 3GPP sends it to ITU for ratification. And ITU has independent evaluation teams which evaluate this technology submitted by 3GPP in other bodies, for example like WiMAX. They look at the technology and see if that technology can meet all the requirements for that particular generation. Okay, so that is the standard process which happened. So 3G, as I said, 3G was CDMA, which was called IMT 2000. 4G or LTE was called IMT Advanced. 5G is called IMT 2020. So currently 5G evaluation is happening in ITU. 3GPP has submitted their technology to ITU. ITU is currently ratifying the technology. Okay, so this is the current status of the 5G technology. So let's look at this 5G a little bit more close now. So this is a very famous octagon. So there are two colors in this octagon. One is the yellow color and the other is the orange. So each of the axes of the octagon represents a particular KPI. The yellow color represents the LTE advanced or IMT advanced. The orange color represents the requirements for 5G, IMT 2020. Okay, so if you look at user experience data, right, that is the vertical axis. What you get from LTE or IMT advanced was 10 megabits per second. What you require from 5G is 100 megabits per second. So you want a 10x increase. Okay, if you look at mobility, LTE advanced was supposed to serve users who are moving at 350 kilometers per hour. Mainly this is for high-speed trains. This has been increased to 500 kilometers per hour for mainly for bullet trains in China and Japan. Okay, so that people on the high-speed trains can also be connected to the 5G network. If you look at the latency requirement for 5G is 1 millisecond. Okay, so we'll talk about this latency in a little while. The next axis is the connection density. If you look at connection density, it says that 5G should support 1 million devices per square kilometer. So what this means is this is something related to IoT. The number of IoT devices the 5G should support per square kilometer is 1 million devices. This is the next metric is very interesting. It's called network energy efficiency. This is the first time this metric was introduced. So they took LTE as the baseline, so they call it 1x. They say that the network should be 100 times more energy efficient than LTE. Okay. Similarly, the peak data rate goes to 20 gigabits per second. Okay, so this is a very pictorial representation of some of the KPIs that are there defined by ITU. Okay, so when they're defining these requirements, what are the use cases they had in mind? Okay, so this is very important. So finally, the use cases are more important for a business sense and for deployment. So when ITU makes the requirements, they also look at the use cases, multiple use cases. So one of the use cases they had was enhanced broadband. Okay, so essentially they want to increase the speed of broadband. They want cellular systems to look like mobile Wi-Fi. Okay, they want higher and higher data rates. They want us to watch 4K video, Ultra HD videos on mobile phones. Okay, and of course there's this whole webcams and surveillance cams across the city. They want them to be connected to the cellular network. That's one application. Another application is ultra dense. So if you are in a cricket match, or even if you are stuck in a traffic jam in India, you can immediately see that the throughput in your cell phone falls down drastically. Okay, so LTE was not designed to take so many number of users at the same time. So they want 5G to work in this kind of large number of user scenario also. One of the interesting things is the tactile internet. So what they mean by tactile internet is they want our touch, our movements to be sent across the network, so that they can operate machines at a faraway place using the 5G network. Okay, so this puts a huge requirement on the delay and the latency of the network. Okay, of course they want the high speed mobility, they want the vehicle to vehicle connectivity, which is a very growing area. I mean, they want for self-driving cars, which vehicle to vehicle connectivity is very important. On top of this, of course, we require the rural automation and the massive machine type communication, which is nothing but the IoT. So these are some of the use cases that I have put here, and I'm pretty sure that the number of use cases that can be served by 5G is going to grow as the technology progresses in the future. Okay, so now that we have looked at the use cases and this thing, let's just get into what 5G is, and let's look at some of the main defining characteristics of 5G. What exactly is 5G? Okay, so before we start getting into 5G, I'll just give 1 minute primer on cellular system. What exactly is a cellular system? Okay, a cellular system, a cell, typically consists of one base station. Okay, there's a base station, and there are multiple users. Users can be your cell phones, users can be cars, users can be your IoT devices. Okay, and the base station's goal is to serve these users, essentially transmit data to the users as well as receive data from the users. Okay, so what are the resources that the base station has? The resources that the base station has is a spectrum. Okay, there's a certain chunk of spectrum that every operator buys from the government at a certain price. For example, I mean, for LTE you require about at least a minimum of 5 megahertz, and you can do up to a maximum of 20 megahertz. Okay, that is a spectrum, and that will be located at certain frequency bands. Okay, for example, 1800 megahertz or 800 megahertz, depending upon different operators. So this is a spectrum that the operator buys. So what is the goal of the operator? The goal of the operator is to make more money. Okay, how can an operator make more money? Operator can make more money if the operator is able to serve more number of users. Your technology should not be a limitation to the number of users that you are serving. Of course, other things can be a limitation. That's it. Marketing can be a limitation. That's a different issue. But your technology cannot be a limitation. So you want to serve as many users as possible, and you want to serve them good data rates. You want to give them good latency. Okay, that's when an operator would be able to monetize the amount of money that the operator puts in a spectrum. Okay, so the question is, we already have a 4G network, and that is doing a very good job. Okay, that's doing a good job. All of us are able to now watch movies on phones. We're able to do video conferencing on phones using 4G network. So what can 5G do? How can 5G do this better than 4G? What makes 5G better than 4G? I mean, is it going to improve all these things drastically? And what are the underlying technologies that enables it to do this? Okay, so that is what we are going to look in the next few minutes. So 5G is, there are lots of changes in 5G in contrast to 4G. Actually, it's a completely different from 4G in some sense. What I'm going to focus on are 5 key technologies, okay, that I at least believe make 5G worthwhile. Okay, so these are the five technologies that actually make 5G much better than 4G. Okay, so one thing is better signals. What I mean by better signals? Actually, you are transmitting your data in a wireless form from the base station to the UBs. So what happened in 5G is these waveforms were optimized in a much better fashion compared to 4G. Okay, that's very, very important. So that is the heart of the entire cellular system. So the signals that are sent from the base station are much more optimized in 5G compared to 4G. And the second thing is very efficient transmission, okay, which is also called massive MIMO. Okay, I'll explain this in great detail in the next coming slides. The third thing is green signaling. Okay, what I mean by green signaling is essentially we have this KPI, key performance indicator, about the energy efficiency of the network. So this particular UV oriented design is a key technology or a key method to achieve this kind of energy efficiencies that are required. Another key design principle was called the low latency design. Essentially, you want a faster response so that you can play online games or you can do control systems on the 5G network. So this required a completely new way of thinking about the way signaling happens or the way the waveforms are transmitted. This is called the low latency design. And the final and one of the most interesting things is the larger bandwidth. So if you look at a 5G system, the 5G systems generally can operate on larger bandwidth compared to 4G systems. For this, they had to introduce a completely new set of frequencies called the millimeter wave frequencies. Okay, so that has its own challenges as well as improvements that provides a huge improvements in the throughputs that you get from 5G. Okay, so we'll go through each of this in some detail. So I'm going to just give you a brief overview of what OFDM is. Okay, a bird's eye view of what OFDM is. Okay, so a cellular system, a base station, has to serve multiple users. It has to serve about, it cannot serve only one user at a time. It has to serve so many users so that each of them has a good data throughput. So given a bandwidth, given a piece of spectrum to a particular operator, how can an operator or a base station serve multiple users at the same time? Okay, the answer is very, very simple. This has been there from the time of 1G. You actually divide the spectrum. You divide the spectrum into small chunks, the frequency spectrum, and use each of this frequency spectrum to serve each user. Okay, and once the set of users are being served, you give this spectrum to a different set of users. You do this fast enough so that users don't find any breaks in their service. Okay, so this is called frequency division multiplexing. So this was what I was talking about in 1G. Okay. So what is OFDM? OFDM is an extremely smart way of implementing this frequency division multiplexing. Okay, so to implement this frequency division multiplexing over hundreds of users, we require a very efficient way of dividing the spectrum and recovering the data from the small chunks of spectrum. Okay, and OFDM is a very, very smart way of doing this. So OFDM has been there from some time, and OFDM actually got its recognition in 4G as well as in Wi-Fi. Okay, even Wi-Fi uses OFDM. Okay, so essentially OFDM is FDM on advanced version of FDM. Okay, that's good. But isn't OFDM already available in 4G? Yes, the answer is yes. OFDM is actually used in 4G, and it is the core of the entire 4G network. 4G or 5G, the main heart of the entire system is this OFDM. Okay, so what is different in 5G? Okay, you can think of 5G OFDM as 4G OFDM on steroids. So essentially what it means is, in 4G, the smallest division that you can make in the spectrum is 15 kilohertz, whereas in 5G provides multiple such options. You can do a 15 kilohertz spectrum for each user, or you can do 30 kilohertz for 240 kilohertz or 120 kilohertz. Not only that, you can mix and match things, okay, which is not at all available in 4G. So this has huge implications on the way we are able to serve users. So users with, so you will be able to pack users in a much more efficient manner when you are serving them. Okay, and this also has implications on the latency. That's not required for this talk, but so essentially OFDM is a very critical thing for this entire 5G, and 5G OFDM is a much more advanced version of 4G. The next most important technology in 5G is called massive MIMO. MIMO stands for multiple input, multiple output systems. Okay, so what I mean by massive MIMO? First, even before go to 5G, let's look at 3G and 4G to some extent. If you look at 3G and 4G, these are primarily, if you look at the antennas on the base station, there are only one antennas or at most two antennas. Okay, so what happens is when you transmit a signal in one of those antennas, the signal actually goes all around. It just comes out of the antenna and then goes in a 120-degree sector across across the entire area. Okay, and the hope is that there is enough power for the UV to receive. The UV, the cell phone will be at some point, and the base station is transmitting all around, and hopefully the UV will be able to receive enough power to decode the signal and run the applications. Okay, so this paradigm is being changed in later versions of LTE as well as in 5G. Okay, the mantra is you do not transmit signal where it is not required. Okay, so when you transmit everywhere, you are actually wasting a lot of transmit power to you are transmitting it to unnecessary places and wasting a lot of power. Okay, so instead of doing that, what they wanted to do in 5G was have targeted beams, have beams which point to a particular user, serve that user, and then change the beam to some other user. Okay, so you have multiple beams which focus energy to particular users. Okay, because of this, what happens? There's lesser wastage of energy, and you will be able to serve users more efficiently. Okay, now the question is, how do you get these beams? It's very easy to talk, but how do you get these beams? So the technology that enables us to do this is called the massive MIMO. Essentially, instead of transmitting on one large antenna, you transmit on hundreds of smaller antennas. Okay, when you transmit on hundreds of smaller antennas, you can actually do something called as beam forming and form multiple narrow beams which can point in any direction that you want. Okay, so you form these multiple beams and you use these beams to serve different users. In this way, actually you beam to the required users rather than transmitting your energy all around. Okay, so this also has some implications on the capacity of the network. So there's this famous formula by Shannon which relates the signal to noise ratio to the capacity. So I wrote the formula at the end, at the bottom. It says capacity is equal to N times W times log 1 plus signal to noise ratio. So signal to noise ratio is the power that you receive is proportional to the power that you receive at the receiver. What is N? In the downlink scenario for the cellular system, N corresponds to approximately to the number of antennas that you have. Okay, so if you are smart enough, if you do these things in a smart manner, then your capacity can actually increase. The amount of data rate that you can pump to the users can actually increase with the number of antenna elements. Okay, so it helps in two ways. So this massive MIMO solution helps in two ways. One is it increases your capacity, and second is it helps you to focus your energy to the users to whom you want to send the signal to, rather than spreading it all around. Okay, so this is a very key technology for 5G. And the third technology is the UV oriented design. Okay, so what I mean by UV oriented design, so to understand this, first we have to look at LTE. So in general, a base station serves multiple users, and it's common sense to understand that when in a morning or in an office time, the number of users that the base station should serve is larger, whereas in night times, the number of users that the base station should serve is relatively much lower. Okay, because people are sleeping and people are not using their mobile phones. Okay, but it turns out, from the base station perspective in LTE, the base station still has to transmit signal across the entire bandwidth, whether it's morning or night. You cannot shut down or decrease the power in certain frequency bins for the base station. That is not possible in LTE. Okay, the reason is there are certain signals called paging signals that are paging and reference signals that are transmitted by the base station across the entire bandwidth in LTE. Okay, so this makes the sleep cycles and power savings much more difficult in LTE. So what they thought was in 5G is a very UV oriented design. Essentially it says signals are only transmitted when there is a UV and to that particular UV. Okay, you generally do not transmit reference signals or paging signals all across the entire band. That's not allowed in 5G. Okay, so essentially what happens because of this, you can shut down parts of the bandwidth. You don't have to transmit on parts of the bandwidth when the users are not there, and you can put the base station to much more efficient sleep cycles. Okay, so this overall will increase the power efficiency that of the entire network. Okay, so remember we have to meet the goal of 100x times more power efficient than LTE network. Okay, so this is one way of doing that. Okay, the fourth important piece of work is low latency design. If you look at 4G, the end-to-end delay requirement is 10 milliseconds in 4G, which is actually pretty good. In 5G, this has been increased, this has been decreased. The delay requirement is made more stringent to 1 millisecond. Actually, 1 millisecond is very, very good. It's very, very difficult to achieve. Okay. So how do you achieve this low latency design? Low latency. Essentially, if your packet itself, the packet through which you are sending your data itself is very, very large, then the delay of transmission itself will increase. So essentially, 5G introduces the notion of shorter packets at the physical layer itself. Okay. So this implies lower latency and lesser delay. Another important thing that's introduced in 5G is called preemption. What this means is, suppose an important control packet is coming that you have to, it has a certain timeline by which it should be transmitted to the UV. You can do preemption. Essentially, you can stop everything else and transmit this packet. Okay, that is one other thing that they have design change that has been made to facilitate this low latency design. And then, of course, they had to optimize the entire core network so as to get this 1 millisecond. Okay, 1 millisecond is a very tight constraint, and achieving it is not an easy task. But this is absolutely required if you want to do control applications on cellular systems. Okay. And the final thing that I believe is absolutely necessary is the millimeter wave systems. Okay. So if you look at the Shannon capacity that I wrote at the bottom, one way is to increase the number of antennas. The other way to increasing the capacity is increasing W. W is nothing but the bandwidth of a system. Okay. So if you look at LTE, the maximum bandwidth that an LTE system can support on a single carrier is 20 megahertz. Okay. In 5G, you wanted more and more bandwidth. Okay, you want hundreds of megahertz of bandwidth so that your data rates can scale drastically. But where do you get this bandwidth? If you look at the spectrum, most of us are aware that spectrum is an extremely scarce resource, particularly in the lower frequencies. Particularly in frequencies around 700 megahertz, 1800 megahertz, or 2.7 gigahertz. 2.7 gigahertz or 800 megahertz. So you cannot get this kind of bandwidths in 400 megahertz or 100 megahertz bandwidth in in the nice cellular frequencies. So what engineers thought was, why can't we move to higher frequencies? Why can't we operate in few tens of gigahertz? Why can't we operate more than 20 gigahertz? Okay, so that is exactly what they did in 5G. They introduced this millimeter wave bands. Millimeter wave bands are the frequency bands which are above 20 gigahertz. Okay, so what happens when you introduce bands above 20 gigahertz? One thing is, there's a lot of bandwidth available in this millimeter wave bands. In some countries there are few gigahertz available in this millimeter wave bands about 20 gigahertz. So you can get extremely large bandwidths available for your cellular operation. Okay, larger bandwidth means larger data. More data rate you can get. But what is the flip side of this? The flip side of this is, as your frequency is increasing, your signal propagation becomes more and more difficult. Okay, so what I mean by that is, at higher frequencies, the loss of the channel, if you transmit 1 watt, the amount of loss you get around 28 gigahertz is much more higher compared to the loss you get at 700 megahertz or 2 gigahertz. Okay, so to combat this, you have to use something called phased arrays. Okay, these phased arrays are very commonly used in radar applications. By the way, millimeter wave phased arrays are used in radar applications. Okay? So this introduction of millimeter wave bands in 5G opened up a huge areas of innovation in terms of devices, in terms of making these phased arrays, in terms of developing technologies from beam steering and beam management. Okay, so according to me, these 5 key technologies make 5G much more better and resilient to the future, compared to 4G. Okay. So going ahead, what? So currently 3GPP is designing release 50 the release 15 is out from 3GPP. The specification is out, and that is what a lot of operators and UE vendors are implementing. Release 16 is in works, and the release 16 should be released. Should be out in a few more months, and subsequently this will be followed by release 17. So each of them adds on the previous release and introduces more and more favors, more and more features. Okay, so what I can say is the current 5G specification is a nice framework. There are lots of things you can do with the existing 5G specification itself. There's so many things that you can add and you can configure and you can make your system much more better. Okay, a lot of new technologies are possible in this framework, and I believe that in this decade, from 2020 to 2030, these new technologies will get absorbed into this 3GPP releases. For example, one of the technologies is full duplex, where you can simultaneously transmit and receive. Okay, so this is one such technology. Another technology is vehicle to vehicle technology. Okay, that will also become part of this 5G technology. Okay, so essentially what we have is a very flexible framework called 5G, and we will be able to do a lot of things with this framework. Okay, so this kind of ends some of the highlights that I want to talk about 5G. So now what I'm going to talk about is what are we doing in India to building systems for this 5G specification. Okay, so essentially government has been helping out researchers and academic institutes to work on 5G from some time. Okay, but to really understand a system as complicated as 5G system, you have to build it. Only when you build it, you start seeing a lot of finer details that are not visible when you are when you do research. Okay, so towards this effort, a bunch of institutes got together with the help of government and are started building something called as 5G testbed. Okay, so I'll give you a brief overview of the 5G testbed that we are developing in India, and conclude at that point. Okay, so what is meant by 5G testbed, and why do you require 5G testbed in India, first of all? Okay, so you require a 5G testbed to implement the 5G technologies that we have developed in India, one thing. And second thing is to be actually at the forefront of technology. You understand 5G better, and to understand all the nuances, you require to build stuff. That's the only way you can understand things at a much more deeper level. Okay? So this ties in very well with the Make in India program, Startup India program that the government has. The government is pushing. Okay. So how do we build a 5G testbed in India? This is the first time we are building a testbed in India. How do we build this? There's a lot of wireless expertise across India. Both in industry as well as in academia. So get all of them together and somehow build this end-to-end 5G systems through which you can demonstrate and research the upcoming technologies. Okay. So what are the major goals of the 5G testbed? One is to encourage existing telecom product startups in India. Essentially new startups, instead of starting at ground zero, they can use the technologies that have been developed in the testbed and build upon them. The second goal is to increase the R&D capability on the 5G technology in Indian markets. Okay, so essentially when you build such a thing, when you build a when you do a project like 5G testbed, you actually train a lot of people, you train a lot of students. These are the students who are going to work in startups and going to work in companies and build up products there. Okay, so this essentially is a huge capacity enhancement of the 5G technology skills. Okay, in addition to this, we want to increase the participation of India in 3GPP and other global forums. Okay, so this 5G testbed has been funded by the Department of Telecommunications, which we call DOT. It's a 3-year project it's already we are 1.5 years into the project. There are 8 institutes involved in this project: IIT Mumbai, IIT Hyderabad, IIT Madras, IIT Delhi, Indian Institute of Sciences, IIT Kanpur, CIVIT is for Center for Excellence in Wireless Technology. It's close to IIT Madras. Samir is the Center for Electromagnetics and Antennas. It's a mighty institute. So there are about 260 people currently working on this 5G testbed project. And okay, we also engage with a lot of Indian telecom startups for various subsystems. Okay. So what is the goal of this 5G testbed project? The goal of the 5G testbed project is to build an end-to-end system. What I mean by an end-to-end system, we are planning to build a base station. We are planning to build some UVs, not the larger form factor UVs. We are building the core network, the front hall, all the components of a 5G system indigenously. Okay, that was the goal. It's a lofty goal. So there are a lot of people working on this particular project. Okay. So this provides you roughly the work breakup between all the different institutes. This is not fixed. But more or less this highlights what each institute is doing. So IIT Madras is focusing on mostly on the hardware and the parts of the software for the base station. Okay. IIT Hyderabad is focusing on SIG and L1, L2, L3. IIT Mumbai is focusing on the core network. So what are the major subsystems that are being developed in this 5G testbed project? We are developing millimeter wave radio front ends. So essentially we are developing phased arrays at 26 gigahertz and 28 gigahertz. Okay, we already have working systems in this. And this is, so everything is also being integrated with the L2, L1, L2 and L3s of the physical layer specification. We're also building a massive MIMO subsystem. We're talking about 64 antennas at sub 6 gigahertz. The entire baseband is compliant to the 5G NR 3GPP specification. We are targeting the standalone mode. So essentially it's a pure 5G system that supports both sub 6 gigahertz and higher bands. The entire core network is being developed. In addition to this, an IoT, NB-IoT SIG is also being developed as part of the 5G testbed. There are some other subsystems, I did not mention everything, but this captures more or less what we are doing. Okay. At the end, what we want is, we want an end-to-end system. What I mean by an end-to-end system, I mean that you should be able to pick up your phone, a commercial phone should be able to connect to the network and make a phone call. Okay, that's what I mean by an end-to-end system. Okay, so we're developing the remote radio heads, we're developing the baseband cards, we're developing the front hall and the core network. So most of these are being developed by some place or the other at one of these institutes. Okay. So as a part of this 5G testbed, a lot of labs are being developed. Okay. So these labs have all the test equipment that you require to test the 5G systems, protocol testers, all the required software to build the hardware, and these labs are also open to outside companies if they want to come and test out their systems. Okay, so these so most of these institutes have state-of-the-art equipment for this 5G. Okay, so I'll now highlight some of the things that we have developed and tell you something about this. So if you look at a base station, a typical base station has two parts. One is called the remote radio head. Essentially, these are the antennas and the amplifiers that sit on the top of the antenna. And you have the baseband unit which sit below the tower, and both of them are connected by an optical cable. Okay. So what I show here is called the remote radio head. This is the system that sits on the top of the tower. What we have here are a 64 antenna system and a 16 antenna system. Both of them, entire hardware and software is developed in-house in these institutions. If you look at the features, this particular remote radio head operates at 3.5 gigahertz. It can do a 100 megahertz bandwidth, which is the specification as per 3GPP. Dual polarized 64 transmitter and receive pairs. And you can pump out 1.5 watt per antenna. Okay, it's a TD system. By the way, it's a TD system. And it's compliant, it's an IP65 system which is 33 close, so you can put it outside, and it has all the required heat sinks and other things. So we also are strictly compliant to ORAN specification. We follow the 7.2 split by ORAN. ORAN is nothing but the Open RAN Alliance. Okay, so that defines some of the base station splits. Okay. On the right side, I have showed you who is developing what. Antennas have been developed by Samir. The RF, FPGA and front hall have been developed jointly by IIT Madras and Samir with the help of some Xilinx people. The L1 software is developed by a bunch of us. A lot of institutes are involved in developing the baseband software. So this is the remote radio. This FR2 remote radio head is the radio head for millimeter wave systems. So this particular radio head operates at 28 gigahertz. It's a phased array. It's a 64. It's a 64, and you can see the picture of a 64 antenna phased array that has been developed by Samir. It's a completely indigenous project, and we are able to test out the beamforming and other things at this 28 gigahertz in our system. Okay, so we have used the facilities at Samir to do the testing for this. And again, as usual, this follows all the requirements of the 3GPP. One of the salient features is it's a 400 megahertz system. So this can support, this particular remote radio head can support 400 megahertz of bandwidth. So on baseband unit, we have taken up an interesting, so if you look at commercial baseband units, they are like COTS hardware that you put in specific, in custom chassis. What we have decided was, we will develop baseband units using PCI Express. Okay, the reason is, we believe that going forward, cloud, the radio access network, most of the parts of the radio access network will go to a cloud. And if we have these baseband units as PCI cards, you can put these PCI cards in data centers and you can run optical cables to the remote radio heads. This way, essentially what you can do is you can cloudify your baseband processing. Okay, so we have developed a custom PCI hardware for this. These have been tested out, and these exactly have a form factor like Tesla cards, if you NVIDIA Tesla cards. And we use a FAPI, standard FAPI interface to interface with L2 and L3. Okay, so this hardware is developed by this PCI Express hardware is developed by IIT Kanpur. The software and other things, we are doing a joint development across multiple institutions. If you look at core network, the core network is a complete ground-up development. So we have started at scratch, and the entire core network is built on a service-based architecture. Okay, so this core network that we have developed has been tested out. It has been tested out for interoperability with a lot of commercial stacks, and we are seeing very, very good throughput. Okay, so currently all the layers L1, L2, L3 on the custom hardware are being interfaced, and there has been some success in this. So there's IIT Hyderabad is developing an NB-IoT chip. This is as per 3GPP spec, completely compliant to 3GPP spec. This also has RF on the ASIC, a very highly, very good power management, and you can also take in inputs from various sensors and relay the data using the NB-IoT protocol. Okay, so this is being developed by NB-IoT. Okay, so what are the use cases for this testbed? So once the testbed is operational, we are going to open it up to various research organizations, universities, and industry. People can come and test these various modules and ideas on this testbed. In this development stage also, it's very easy to collaborate and become part of the testbed. Already multiple companies are partnering with us on this testbed, and it depends on your requirements and what you want to do with the testbed. Okay? So essentially what we are looking for meaningful collaboration with academic institutions and various industry partners on this testbed. Okay. So thank you. That concludes my talk. I'll be happy to take up questions at this point. So let me just look at the questions that people have posted, see if there are. Okay, so first I will talk about the questions that have been posted on the Google Sheets. Let me just look at this. There are like 200, 150, 110 questions in this thing, so I'm just going to pick up a few questions and try to answer them. So one of the question that has been posted multiple times is there any health uh, effect of 5G? I mean, effect of what is the effect of 5G on health? I'm not a correct person to answer this. At least my personal opinion, there is no effect of 5G on the health of an individual. Of course, you should not talk too long on any phone. That's a different issue. But from a strictly technology perspective, I don't think there is any effect. Again, this is my personal opinion, and I think more work is being done in this particular area, and we'll understand this as time progresses. Okay, so one of the other question that I see is, I think 4G technology should be improved instead of focusing on 5G technology. So let me answer this question. So 4G technology is being improved from the last 1 decade. Okay, as I told you earlier, 4G technology started around 2010, and it's almost been a decade. There have been a lot of versions of new versions that have come up in the 4G technology. So at some stage, what happens is you have to change the base. Otherwise, whatever you do is a patchwork, and that is what engineers are realizing. Engineers and standardization experts are realizing in 4G, that it has worked well, it has done its job. It's time to move on to a newer and more flexible standard called the 5G. Okay, if you want to do something more on 4G, you can certainly do, but it will be a patchwork. Okay. So another question that I see is NOMA is used in 5G instead of OFDM. See, NOMA is one more feature that is enabled in 5G. You can actually use that is currently being studied in release 16 and release 17, and hopefully that will be part of the upcoming generations. Another interesting question that I see is, what about satellites? Can satellites become part of 5G? Okay, so this is a very interesting topic. So essentially now satellite companies want to do terrestrial communication. They want to be part of the cellular infrastructure. So I think there's a lot of work that has begun in both ITU as well as in 3GPP in enabling satellite based communication for 5G. Okay, work has started. It's still in the initial preliminary phase, and we hope that they'll also become part of this 5G journey. Okay. Another interesting question I see is, why are average 4G speeds in India slower compared to other countries? Okay, there are a couple of reasons. One is the bandwidth that has been allocated in India is a little bit lower than what has been allocated in other countries. That's one reason. The second reason is the number of users in India is much more larger compared to other countries. Okay, so because of this, the same bandwidth is being divided across multiple users, thereby reducing the speed of each user. When will we start 5G in India? So that's a very interesting question. I mean, I hope that in a year or so we should see some kind of 5G deployment in a year or two, hopefully. How does the 5G 4G transceiver of a phone and a base station differ? Okay, so the transceivers on the 5G and 4G differ, one in the frequency bands that you have, and the second thing is the bandwidth that it will support, and the third thing is the RF specification for 5G. RF specification for 5G is a little bit more tighter than what is there in 4G. So your front end has to change, both the base station and then the UE. Where does India stand among the world leaders in 5G technology? As I was telling earlier, government of India is seriously looking into the 5G deployments. There's a high-level forum that has been formed to understand what are the spectrum requirements, what are the technology requirements for 5G in India, and government is actively looking at understanding how 5G can be deployed in India. Another interesting question is, what are the error correcting codes in 5G? Okay, this is something I did not touch upon. So every communication system uses error correcting codes, which is also called the FEC, forward error correction codes. In LTE, the error correction codes are called turbo codes. Okay, in 5G there has been a big shift on 5G doesn't use turbo codes at all. In fact, 5G uses two different codes. One is called the LDPC codes, low density parity check codes, and the other are the polar codes. Okay, so LDPC codes are used in the data path, whereas polar codes are used in the control path. Okay, so this is again a big shift from 4G to 5G. Okay, LDPC codes are very good implementation in terms of power and performance. So another question is that we are using higher frequencies in 5G, but they cannot be used to serve longer distances. That's absolutely true. So to combat this, you used phased arrays. Okay, if you use a single antenna without proper gain, then the higher the frequency, the lower the distance. But if you can actually use phased array properly, then actually you can maintain the same distances even though they are higher frequency. Essentially, you use more and more antennas. Okay, so to both transmit and receive. So there are a lot of questions on the security aspects associated with 5G technology. I think there's a lot of work put in by 3GPP on the security aspects of 5G. I'm not an expert on that, so I'll not be able to comment. But I know for a fact that 3GPP has done a lot of work on the security of 5G. Another question is whether 5G uses only OFDM technology or a mixer of multiplexing and modulation technologies like CDMA and OFDM. So actually 5G uses OFDM in both uplink and downlink, as well as single carrier FDMA in the uplink also. Okay, that's the difference between LTE and 4G and 5G. One more difference: in LTE, the uplink, the transmission from UV to base station is based on SCFDMA, which is single carrier FDMA. Whereas in 5G there are two options: you can either use single carrier FDMA or you can use OFDM. So another interesting question is there any limitation on massive MIMO deployment? Currently we are deploying 32 transmitter and 32 receiver. Okay, so of course, one thing is, of course, the size of the device and other things also matter. More than 32 or 64, it's the size of the equipment, base station equipment becomes larger and larger. And the second thing is, the number of pilots that are there for channel sounding has some impact on the number of antennas that you can put. Okay, so you should use some analog beamforming combined with digital precoding. Is there any possibility of implementation of non-orthogonal multiplexers in 5G? Yes, the answer is yes. Actually, this is already a study topic in 3GPP. NOMA is a very active study topic in 3GPP, and it's going to be part of the future specification. So there are lots of questions on use cases. So essentially, one thing that you have to understand is 5G tries to cover a lot of use cases. It's looking at smart cities, it's looking at IoT, it's looking at enhanced mobile broadband, means larger, higher data rates, it's looking at low latency. So the use cases for 5G are just, can be left to your imagination. I think as we progress forward, once we get more concrete 5G deployments, applications are going to actually start utilizing the full power of 5G. Okay. So some of the questions are, how do we access the 5G testbed? As I mentioned earlier, you can contact one of us, and we'll be happy to put you in touch with the right people to access the 5G testbed. Okay, we are looking for collaborators, and if you're an Indian company, we'll be more than happy to help you out. So another interesting question that we have is, what about the role AI is going to play in 5G technology? Okay, that's actually a very interesting question. 5G, one of the advantages of 5G is it has a lot of flexibility. There's so many parameters that you have to configure for 5G, okay, and that is its drawback also. So to really configure a 5G system and to optimize it, it's not going to be an easy task. Even for that sake, deploying a 4G system and tuning it to the requirements is not at all easy. And 5G, it's going to be much more difficult. Okay, so that is a place where AI is going to play a role. I can immediately see. Of course, there are other places where people are looking at AI in the cellular systems for channel estimation and channel equalization. In addition to that, even configuring the 5G network and keeping it optimal is a good application for AI. So one of the questions I see is it possible to disrupt an entire 5G network with a few devices because you are using beamforming? The answer is absolutely no. Okay, the beamforming is done by the base station. Okay, so if the UV is not able to receive the beam, the base station will move to the next UV, or it has a particular protocol to change the beam patterns and other things. Okay, so this is all taken care by the beam management protocol in the standard. Okay, is 5G possible to be designed with FDD mode? Okay, the answer is yes. 5G operates both in FDD and TDD modes. In general, if you want to do massive MIMO deployments, it's better to use TDD because you can use channel reciprocity. On the other hand, the 5G standard is designed to use massive MIMO deployments even for FDD, but there are a few drawbacks for that. Okay, one person is asking, what about full duplex in 5G? So there's already so if you look at LTE or 4G, the uplink downlink structure, it's also called the TD structure, is very fixed. There are only 7 configurations of the uplink downlink ratios, and you have to choose one of them. Okay, but whereas in 5G offers an extremely flexible TD structure. Okay, you can configure uplink downlink on a UV per UV basis if you want to, or you can do it on the entire network basis. And not only that, you can actually change the uplink downlink pattern on a slot by slot basis. Okay, so all the ingredients to make a full duplex network are already there in 5G, but there's more studies that are required on the RAN 4, on the RF side of things, before full duplex can be enabled. Okay, so the progression that is going to happen is, currently people in 5G are looking at flexible duplexing. Once flexible duplexing takes place, then people will start looking at full duplex. Okay. Okay, let me just look at a few more questions and then we can conclude. What is your roadmap for the 5G testbed towards ORAN? I mean, so if you look at the 5G testbed, we are trying to follow the ORAN specification. For those of you who don't understand what is ORAN, so if you look at 4G network, there are two important parts. One is called the remote radio head and the baseband unit, and there is a optical connect between remote radio head and baseband unit. Okay, so this is a protocol called ECPRI protocol, Enhanced Common Public Radio Interface Protocol, ECPRI protocol. Sorry, it's called ECPRI, not it's called CPRI protocol. Okay. So it turned out that there were some vendor-specific flags in that CPRI protocol, so that if both the base BBU unit and the remote radio head unit has to be purchased from the same vendor. So to avoid this, there was an alliance formed called the ORAN Alliance, which actually made something called Enhanced CPRI protocol, eCPRI protocol, along with a lot of other specification, by which you can separate out the BBU and the RRH in a more intelligent fashion. And 5G testbed is following this ORAN's protocol. We are following split 7.2. There are lots of questions on network slicing and SDN. I mean, actually, I'm not I really don't understand these things very well. So it may not. I mean, I don't want to speak about these particular two topics, but they are very, very important for the core networking in 5G, and they are important to maintain the latency and the network requirements of 5G. That's all I can say at this moment. I think I cover all the varieties of questions that I have. Actually, one more thing, a lot of people are asking about how do we understand 5G. There are lots of courses that are being put up on NPTEL and other places which have good 5G material. I would suggest you to look at that. There are already textbooks that are available for 5G. So one of them is this 5G NR, Next Generation Wireless Access Technology by Eric Dahlman. And there's another book by people from Xilinx. So all these are good textbooks. So you can start reading and understanding this 5G technology from there. Another question I see is filter bank multi-carrier technology part of the standard? No, unfortunately no. We have OFDM is the only waveform that is there in the standard. Okay. A lot of people are asking about the cost of 5G network. Of course, it's going to initially be expensive, but as time progresses, the technology cost is going to decrease with a more number of users and more deployments. So I think I have covered more or less most of the questions that are there, varieties of questions. So we can, I think I will stop this stream at this moment. So thank you for attending this talk. It was very nice talking to all of you and looking at your questions. Feel free to contact me if you have any further clarifications required. Thank you.